So let's continue simplifying rational exponents, radicals. This particular lesson is titled Simplifying Radical Expressions. Again, we're going to review all of our perfect squares, listing them out above. That way, it's a reference for us as we solve these problems below. You can see below where we will need those perfect squares. It's 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225 finishes us out 15 times 15. Our perfect cubes, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 27. 4 is going to be 64. 5 is 125. 6 is 216. 7, 343. 8 is 512. 9 is 729. And 10 makes 1,000. So now we can look at simplifying our radicals. Number 1, the square root of x to the 14th. I want to piggyback off our last lesson, and I want to remind you that this is a square root of x to the 14th. And let's use that rational exponent rule. I can rewrite this as x to the 14 over 2, which simplifies to x over 7. So I know we have simplified radicals before, and we have simplified variables in our radicals. But now let's kind of make the connection with that rational exponents. And you can see now why the square root of x to the 14th is x to the 7th. Number 2, we have the square root of 81. I am going to write them separately here. And the square root of x to the 6th. We know the square root of 81 is 9. And again, I'm going to rewrite the square root of x to the 6th as a rational exponent. And then I can simplify that as 9x to the 3rd. Final answer. Number 3, we have the square root of 36 and the square root of x to the 10th. I'm going to do the same thing we've been doing before. The square root of 36 is 6. And then I'm going to rewrite the square root of x to the 10th as a rational exponent of 10 over 2, or 6x to the 5th. So you're going to see Delta Math in your practice is going to be using those same rational exponent rules, simplifying it this way. Number 4 has 3 things in that radical. We've got the square root of 64, the square root of x to the 4th, and the square root of y to the 15th. So the square root of 64 is 8. Let's rewrite it as rational exponents, because this is the way you'll see it on your Delta Math practice for this week. The square root of x to the 4th as x to the 4 over 2 to the 4 halves, and y raised to the 15 over 2. Simplify where you can, so we can change this to 8x squared, but we'll leave the y because we cannot simplify any further. And again, the Delta Math practice you have this week is correlating with your rational exponent, so you'll see answers in this form, y to the 15 over 2. And that's our final answer on that one. Number 5, I'm going to separate them again. Square root of 100, square root of x to the 7th, and square root of y. The square root of 100 is 10. I'm going to change x to 7 over 2 and change the square root of y to 1/2. And if I could, I would simplify, but I can't. So I'm just going to write this as my final answer, 10 x to the 7 halves, y to the 1/2 is my final answer. Number 6, you've got the square root of negative 16, also square root of x to the 15th, and square root of y to the 7th. So you should know this. Algebra 2, do you see this? Do you see this? The square root of a negative. You know you can evaluate that as 4i. There's your imaginary unit. So popular in Algebra 2. We're going to see imaginaries everywhere. Rewrite the x to the 15th as a power rational exponent, 15 over 2, and y to 7 over 2. If I could, I would simplify, but this is going to be my final answer, 4i x to the 15 over 2, y to the 7 over 2 would be my final answer there. Number 7, square root of negative 36, square root of x to the 6th and square root of y to the 14th, I can evaluate the square root of negative 636 is 6i. I'm going to rewrite the square root of x to the 6th as exponent 6 over 2 and y as 14 over 2, and simplify where I can. So 6i x to the 3rd y to the 7th. Final answer. All right, number 8, we are going to switch over and look at cube roots. So starting with number 8, we will see cube root examples. We got the cube root of x to the 12th. So again, remember your index becomes your denominator. So if I rewrite this in rational form, and then I can simplify, 12 divided by 3 is 4. Cube root of x to the 12th is x to the 4th. Number 9, we've got two things. We've got a cube root of 64, and we have a cube root of x to the 6th. We made that list at the top. So the cube root of 64, that's a perfect cube of 4. And then I'm going to rewrite the cube root of x to the 6th as 6 over 3 there. So it's 4x squared when I simplify that rational exponent. Number 10, we have the cube root of 125 and the cube root of x to the 21st. Cube root of 125 is a perfect cube. That is 5. I'm going to rewrite the x to as 21 over 3. And then when I simplify 5, x to the 7th is my final answer. Our last two here, we have the cube root of 27, a cube root of x to the 7th, and a cube root of y to the 15th. The cube root of 27 is perfect. That's 3. I'm going to change this to x raised to the 7 over 3 and y to 15 over 3. I can't simplify those any further. I'm going to leave it that way. That will be my final answer. You'll see that modeled on Delta Math. They will leave it in rational form. And number 12, we've got the cube root of negative 64, the cube root of x to the 15th, and the cube root of y to the 9th. Now, a big deal. I want to make sure that you notice this cube root of negative 64. That is negative 4. I want to put a note over here that you can take cube roots of negatives. You can take cube roots of negative numbers. Okay, so through our Algebra 2 curriculum, we do see those negatives in our radicals, and we go imaginary. Negative in my radical, imaginary. That is for square roots. Majority of the time, absolutely. But cube roots can be negative, because negative 4 times negative 4 times negative 4. When I multiply the first two together, it gives me positive 16. And then when I multiply again with that third negative, gives me a negative 64. So you can have cubes that are negatives, okay? This is not imaginary. This is going to be just negative 4. And then I'm going to finish simplifying the x, change it to a rational exponent, and y, change to a rational exponent. So our final answer is going to be negative 4, x to the 5th, y to the 3rd. Okay, big note there. Cube roots can be negatives. You're not going to have imaginaries with cube roots, so keep your eyes peeled on that one. So that's our big lesson on simplifying radicals. We have simplified radicals before. This is kind of our second time back around as we've now focused on rational exponents and how to simplify those. Those help us simplify here and establish why, like on number 1, the square root of x to the 14th was x to the 7th. We can rewrite it as that square root as a fraction exponent and simplify, and we can see now exactly why that happened. Your Delta Math is going to use rational exponents, and that's why I left them here as rational exponents. So practice that and let me know if y'all have questions. I'll be glad to help you. We'll see these all over our benchmarks and all over our tests in the future. Bye.